In this module, I'm going to give you a very brief overview of sequential decision problems. So let's take all of these applications that I've been working on, and behind every one of these applications is a decision. So if you look at any one of these boxes, it's posing a question in which you have to make a choice. So that choice means there's a decision, but after you make a decision, if you put your eye on any one box, information will arrive that is relevant to the decision but was not known when you made the decision. Let me do this over again. Let's go back, put your eye on any one box, look at the decision being made, and as I step forward, there's the information that arrives that's relevant to the decision that you didn't know when you made the decision. These are all sequential decision problems. Now, when you have a sequential decision problem, information that arrives after a decision is made is not known when we made the decision. This means you're making decisions under uncertainty. Welcome to life. Now, we have inventory ordering problems where you place an order and the inventory may arrive right away or weeks or months into the future. And then this goes over and over again. You placing orders and then you see information such as the demands for the product. Or maybe what Optimal Dynamics does of assigning blue drivers to red loads, assigning drivers over time, but over time information is arriving such as new loads and random delays and equipment breaking down, that sort of thing. Notice that this is high dimensions. You generally don't see high dimensional problems in dynamic programming. Financial trading, every one of these problems are buying and selling assets, and these are portfolio management problems. Again, very high dimensional, being solved over time. Finally, testing new vaccines. What dosage? Which people? How do the people respond? How well does the vaccine work? Here's a problem that doesn't look like a sequential decision problem. It's a facility location problem, a classic integer program, widely solved as such, a static integer program where you have variables to say which warehouses should I build. But in fact, even this is a sequential decision problem. You don't solve it once. You're going to solve this repeatedly over time. When you make a decision about a warehouse, generally you're going to live in that warehouse for years. You may be making these decisions once every quarter, possibly yearly. So the decisions span multiple years. You have to be thinking into the future. Here's material science. I did some work with material scientists. The middle one was the robotic controller, where you have to make decisions. And in this one, maybe we can assume that there's no impact on the physical world of the future, but what does change is what I know, what I have learned, what I believe. In the health sciences, drug discovery, we had a lot of fun with drug discovery. By the way, it's really fun pretending to do research in areas. And these, again, were optimal learning problems that arise in drug discovery. My work in e-commerce, revenue management, ad click optimization, personalized offer. What type of room with what sort of services do you offer? These are all sequential decision problems where there's learning. I had a lot of fun with this energy storage problem. You have energy from a wind farm, or you can pull energy from the grid. The wind farm has highly random supplies of wind. The grid has highly random prices. You're trying to meet a fairly predictable load, say you have a building or a city or a university campus. Then maybe you have a battery storage device to help smooth out the variations. Now, I like this book on sequential decision analytics and modeling. 12 of the chapters are all different applications. These are all sequential decision problems. They come with a model. Again, fairly simple, but this is a wide range of applications. And then, of course, I love to come back to my truckload problem. Think of this as like Uber, but on a national scale, and it's not people getting inside an Uber vehicle. It's truck drivers picking up a load of freight to move the load from A to B and then unload. Very high dimensional, very complex. Now, another class of sequential decision problem is very important. I think this is probably the most widely used sequential decision problem, where I have a set of choices. So off to the left, I have a lot of example settings: what price, what product to advertise, what treatment to use, what drug, what advertising channel. So I have a bunch of choices. I don't know how well they all perform. First of all, I have to define the choices. Sometimes they're obvious, sometimes they're not. I may want to make a new molecule, but I have to design a particular chemical process, I have to come up with the chemical process. Now, the performance of each can be highly uncertain. This is what makes the problem hard. I don't know which one's best. And some of them that may seem good actually aren't. Some of them that don't seem so good might be much better than I think they are. And these learning problems come in a variety of flavors. We have inexpensive experiments that can be experiment can be repeated in microseconds to seconds or maybe minutes. You have expensive experiments. An experiment might take an hour or a day or a week or a month. I can describe problems that take a year. You have offline learning in the lab where you can make mistakes and it doesn't really hurt you. You have online learning where you have to do it in the field and where you have to do it at the speed of light, which is usually fairly slow. One of the problems that I really think is very important, I call it learning while doing. These are complex problems. They're expensive experiments. They're usually high noise, and they're online. They're in the field. By online, I mean you don't have a computer model. You don't have a mathematical model of your problem. You just had to do trial and error. This was the classic setting of reinforcement learning back in Pavlov's dogs. Now, learning problems only have a state which is what you know or believe. It's the belief state. Whereas you can have an entire spectrum of problems from physical resource allocation problems that don't have a belief state, to pure learning problems that only have a belief state, to mixed problems where you're having to manage things in a lab or move a truck around or anything. I have a physical problem and I'm learning at the same time. So if you go to warrenpowell.org, under sequential decision problems, overview, there will be an overview of different sequential decision problems. If you go to teaching materials and then books, I have several books that are available, web versions of the books that are available right from the internet. One called Framing the Problem. Chapter 2 lists the number of applications with no math. And then sequential decision analytics and modeling lists a dozen applications, each which have their own math model.